Hello, I hope you're doing well. Now we're gonna tackle this problem. In this case, it is the problem number 2340, numbers of spiral diagonals, part 1. So, let's see what it says. It is inspired by project Euler number 28 and also 58. An n by n spiral is obtained by starting with the number 1 and moving to the right in a clockwise direction. For example, with n equals 5, the spiral matrix is the following: 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 3 by 3 matrix, and then it goes 10, 11, 12, 13, and it goes on until it completes a 5 by 5 matrix, right? 25 because there are 5 rows and also 5 columns. And yeah, okay, I understand this. Let's see what it says. In this example, the sum of the numbers on the diagonals is 101. So let me check that. Let's take this. We're gonna sum the values on the diagonals. In this case, we're gonna sum here. We're gonna sum here. And we're gonna sum here. And let's see. Here it sums 21, 28, 29, 32, and 45. Okay, so we already get 1, so let's not take this into account, and it will be 17 plus 5 is 22, 22 plus 9 is 31, and 31 plus 25 is 66. So we are not taking into account the 1, so only the other 4 values. And when we add those together, we get 101. So we need to actually, yeah, sum all the values on the diagonals. It's quite easy. What is the sum of the numbers on the diagonals in any n by n spiral, considering that n is always odd? Okay, so the hint is that you want the diagonals, not the whole matrix. You could also make the matrices, but is that not the case? We can check by cases. For example, on a 1 by 1 matrix, oh, on a 1 by 1 matrix, we only will have 1, isn't it? On the case is a 3 by 3 matrix, it will be 3, 5, 7, 9, and we need to add all of them. On the case is a 5 by 5, we will get like 13, 17, 21, and also 25. So we can make maybe like a series. For example, when n equals 1, first we get 1. When n equals 3, we get 1, 3, 5, 7, 9. When n equals 5, we get 1, 3, 5, 7, 9, and then 13, and then 17, and then 21, and then 25. So what do we find here? First, it starts with 1, and then plus 2, plus 2, plus 2, plus 2. Okay, and then for the next 4 numbers, it is plus 4, plus 4, plus 4, plus 4. Okay, and then when n equals 7, maybe we can know it already. It will be plus 6, 26, 27, 28, 29, 30, 31, and then 32, 33, 34, 35, 36, 37, and then we can be sure that this will keep happening. And we use that 6 and 6 and 6, and then maybe with other cases like with 9, it will be like the same. So instead of adding 6, it will be adding 8, and then keep adding 8. And yeah, the answer will be just the sum. So in this case it will be 1, In this case it will be, I don't know, 10, 25, and then here we need to add those values. But actually there is a pattern. What it matters is that we can make a code following this pattern. So we just need to see that there are chunks, one, and there are, this another chunk is just adding 2 to the previous number, plus 2, plus 2, plus 2, plus 2. And then this other group of 4 numbers is adding 4, plus 4, plus 4, plus 4, plus 4. And then the next 4 numbers is plus 6, plus 6, plus 6, plus 6. And we can keep going. So since we can keep going, let's try to make it on code and then get the answer for n, any value of n. Okay, so we already made the code. It was actually quite easy and it's actually quite small if you take into account the hint that was given. So let's see here on the graph how the code works. First, let's show that this is the function version. It's the same that is shown here, so it works well. And here what we try is try some values of x, and let's see, for 3, oh, but we don't get the value. Let me show it like right now. 25. For 5 should be 101, and yeah, we can keep going and we get those values. I haven't checked this manually, but I trust the code because it works for the small numbers, and for sure it should work with bigger numbers because the code has been made correctly. What we do is start with sum, and sum is 1 because for the first example we start with a matrix of 1 and only that. So if we have to go through values bigger than 1, what we're gonna do is calculate the values of the diagonals. We are not creating the matrices, we are just getting the values on the diagonals. So yeah, how do we get the values on the diagonals? Just by calculating as we haven't done previously. This is the code that makes that. We just go from j equals 1 to 4. That means we are adding 4 values of the diagonals, and to know which value is which one, we work with an I. So let me show it here. If we have, for example, a 5 by 5 matrix, what we are adding is 4. So that's 5 minus 1. That's why this I is here. On the case it's a 3 by 3 matrix, what we are adding is 2, 3, 5, 7, 9. And that also works with I minus 1. On the case we go from a matrix of 7 by 7, what we are adding is 6. And yeah, that also checks here. That's why this value here, it actually works for every value that is odd. How do we know that this works? How do we get all the elements of the array that we want to get? First of all, we create an array. It starts empty, and then we add the values. So we start with sum equals 1, and that is 1 plus 0. So at first we're going to have an yes of 1 and 1. Then we do this 4 times and we get 1, 1, 1, 1, 1. So yeah, we check for that later. What matters is that when we go from 3, we go from sum equals 1 plus 2, and that's 3. When we do this again, this value of sum is going to be 3 plus 2, and that's 5. And then when we do this again, sum is going to be 5 plus 2, and that's 7. And we can keep going. And just to not erase those values, we save them on an array. So during all this time we are getting the values 3, 5, 7, 9, and we are saving it on this vector. So we can show it by doing this. Oh my god, let's check for a small number like 3. And yeah, as we have said, at first we get like this problem here that we get repeating values of 1. We are gonna check for that later. And then what we are interested is like we get 3, we get 5, we get 7, we get 9, and we can keep going. If we go through 5, then it not only goes through 9, it also goes to 13, 17, 21, and 25. So this is very good and this works very smoothly. The only problem is that we have repeating values on 1, and we use get uh, get rid of this by using this command, which is unique. So s become unique of s. That erases the repeating values of 1. And at last, this should be the final vector that has all the values of the diagonals. So this is a good example. We don't need to create a matrix. We can just be creative and get the values on the diagonals by other ways. And this is faster. Finally, we get the sum of all the values of the vector. This is easy. We just make a for I equals 1 through the length of s. So it doesn't matter how long is this vector. We're gonna make sure that we're gonna go through all the values. We say that y is equal to 0 and then y is equal to the corresponding value of this vector. So 0 is equal to 0 plus 1, then y is equal to 1 plus 3, and then y is equal to 3 plus 5, and it goes on and it goes on until we get the final value that we show. This is the final value, and it can work for also very considerably big numbers. In this case, on the tests, it goes with 3, it goes with 5, it goes with 9, wow, 501, 5001, wow, 10,001, and yeah, 10,003. So let me check for this and let's end this video with that value. Oh my god. So yeah, that's interesting, very interesting. And yeah, with codes that simple, we can get very big and very interesting values. So make sure that you can also are able to create this type of codes and have fun. I hope you have a good day.